Welcome to qnawire.
All right, so this is an interesting application of a person on an elevator. So that's the floor of the elevator. This is the person. We're going to draw them as a box. But we have a downward force weight, and then a slightly smaller, so I'll just kind of exaggerate, it's just slightly smaller, but again, I want to exaggerate that on my diagram, center of mass right here, normal force acting on this passenger. So let's add numerical values to that. In particular, the normal force is only 620 newtons, but the weight of the passenger is 650 newtons. There's a slight deficit in the downward direction. And then part A is asking us to identify what the Newton's third law, action, reaction forces are for the normal and weight vectors respectively, and they are each other's action and reaction forces, words, and NW are each other's reaction forces. Good. And then part B, see, I have the answer down here is yes, but the question is the passenger accelerating? And yes, the forces are imbalanced. So there will be a net force and therefore a net acceleration in one of the directions. And in this case, that's going to be downward because weight exceeds upward normal force. And lastly, in addition to direction, they also want the magnitude of that force. So we tally up all of the forces. So we know it's going to be downward. So we're going to do weight minus n. That's going to be equal to the mass of the passenger multiplied by their acceleration. Good. So we rearrange this in order to solve for that acceleration and then get weight minus normal force down there. So we're not told the mass, but we do know the weight, so we can make a sneaky little substitution of W divided by G down there, because those are both quantities that we do know. So the weight being 650 newtons, and then the acceleration due to gravity being 9.81 meters per square second. And then up on top, we're going to take the difference. That's 650 minus 620. Put that all into a calculator, and then we get a value of 0.45 meters per square second downward.